All right, my fifth graders, today we're going to be doing Unit 4, wrapping up multiplication and division with multi-digit numbers. Lesson 15, missing side lengths. Our goal today is to use the relationship between multiplication and division to solve problems. Here we have a warm-up. What is the area of one of the large rectangles in the garden? So here's the garden. I have lots of big rectangles. I need to find the area. I need to get my pen out. The area of this section. They look all about equal, right? What I notice is, and remember I'm estimating. What I notice is there's a little man here, or a woman, and a car. So if I can estimate the length of this, right? The length of that, and then split this up into equal amounts, maybe like this. Not real good right now, but there we go. How many of these car lengths would there be, and what is that car length? Even if we estimated this car length to be, I don't know, if this is a man and he's 6 foot tall, I would say that the car length was 12. So that means I would have 12 in each of these, right? And maybe a little bit over. So I know that 12 times 5 is 60. 12 times 6 is 72. So let's estimate that this length is 72 feet. Okay. Then we'd have to estimate the width. Do we think we could use the trees maybe? I don't know. I think that maybe that this would be half of the length. So half of the length. I'm going to do over here. I know I'm supposed to be doing mental math, but 72, let's see, 3 times 2 is 6, 12 left over, so that would be 36, so 36. But remember, we're estimating. So let's round this to 70 and this to, should we say 40 or 30? I'm going to say 30. I'm going to estimate 30. So that would make that about right answer. Remember, 7 times 3 is 21. So that would be 70 times 30. 7 times 3 equals 21. And then I can just add the 10 times 10, which is 100. So 2,100 feet squared is my estimate. That's about right. So what would be too low? 1,000 feet squared, or square feet. And too high, 20,000. That would be too big, right? Feet squared. So we're just estimating, right? We don't have exact measurements. But do you see how I could use that car, the length of the car, and split up this length to help me figure out what a good estimate would be? All right. Again, yours might have been different from mine, but that's the way I thought about it. Let's get into our next activity. The area of one of those spaces was 9,175. 9,175. So I was way off, wasn't I? And they said that the length was 75 feet. Well, that I was pretty accurate with that, right? Because I was estimating. Okay. So the area is 9,175 square feet. One side length was 75 feet. What is a reasonable estimate for the width? Well, I remember that length times width, right? Length times width gives me the area. So that means it's 75 times something is 9,175, right? So an estimate would be how many, the way I would do that, right? I was going to set this up as a division problem. My first estimate would be how many 70s is in 900. So what times 7 would get me close to 900? Well, I know that there's 175 in this 91, so I'm going to go 1 for now. And I'll subtract, so that makes this an 8. So that's 16, and bring down the 7. So how many 75s will be in that number? Well, if I go over here and do 75 times 2, I get 10, 14, 15, 150. So we're going to do 2. 1, 5, 0. Subtract that, and I get 17. I'm going to bring down my 5. Now I just have to know how many 75s are in 175. Well, there's at least 2, right? So let's do 2 again. 2 times 75 again is 150. Did I do that right? 150. Yep. Yep. All right. So that's 150. And how many do I have left over? I have 25 left over. So this isn't going to be a whole number. It's going to be around 122. 122. All right. Okay, let's see what they ask us to do next. How can we find the exact length of the garden? And that's how we did it. We would divide, right? And there's going to be some left over. There's going to be a 25. Oops, sorry about that. Let me go back one. There's going to be a 25 over 75 left over, right? So but what we could do is we could divide 9,175 divided by 75. And unfortunately, this one does not come out evenly. We get a fraction as a mixed number as an answer. All right, let's move on to activity 1, complete the table. So I know from that last activity that length times width is going to give me the area. So in order to find the answer to this, I'm going to have to divide 24 into 816. 24 into 816. Well, I'm going to start with the 2-digit number because 24 will not go into 8. 24 will go into 81. So how many times will 24 go into 81? 24 times, let's do 3. 3 times 4 is 12. 3 times 2 is 6 plus 1 is 7. I think it's going to go in 3 because if I add another 24, I'm going to get over 81. So I'm going to do 3. 3 times 24, I just found out, was 72. So I'm going to subtract that, and I'm going to get 11 minus 2 is 9. And I'm going to bring down my 6. So I've already tried 3. That's too low. So I'm going to now try 24 times 4. 4 times 4 is 16. 4 times 2 is 8 plus 1 is 9. And that is perfect. So I'm going to go back and put that 4 up here. 96. And there is nothing left over. So I know that the answer is 24 times 34. And then I could always check my division by multiplying this out, right? So I know that I'm going to have to multiply this times something to get this. So let's divide to find the answer. 48 goes into 1,248. Well, 48 will not go into 1. There are no 48s in 12. So how many 48s are in 124? I'm going to try 48 times 2 to begin. 2 times 8 is 16. 2 times 4 is 8, plus 1 is 9. That seems a little low, so I'm going to do 48 times 3. 8 times 3 is 24. 3 times 4 is 12, 13, 14. And that is too high, so it has to be 2 times. 2 times 48 is 96. So I'm going to borrow 1 from the 12 and make that an 11. And so now this is 14 minus 6, which I know is 8. And 11 minus 4 is 7. Right? And then I have to bring down, wait, that cannot be right. Oh, it's 11 minus 9, Miss Lemoyne. 11 minus 9 is 2. Yes. Do you know how I knew that was not right? Because there cannot be a number higher than 48 remaining. All right, now I'm going to bring my 8 down. And how many times will 48 go into 288? Well, I know that 4 times 7 is 28. Let's try 48 times 6. I'm going to go 1 down. 6 times 8 is 48. 6 times 4 is 24 plus 4 is 288. And I was right. So 6. 6 times 8 is 288. 6 times 48, I should say. with 0 left over. So this answer will be 26. Again, I'm going to multiply length times width, and that's going to give me area this time. So I'm going to do that one over here. 253 times 23. 3 times 3 is 9. 3 times 5 is 15. 3 times 2 is 6, plus 1 is 7. I don't need that 0 anymore, and I'm done with the 3. Now I'm going to really say 20 times 3 is 60. 2 times 5 is 10. And 2 times 2 is 4, plus 1 is 5. 9, 11, 8, and 5. So 5,819. All right, we have one less to do. What times 36 is 5,796? I'm going to get a different pen just so we can tell the different work that I'm doing. So again, I'm going to have to divide 36 goes into 5,796. Well, there are no 36s in 5, so I'm going to put an X there. How many 36s are in 57? Well, if I double 36 times 2, I think it's going to be too big. Yeah, it's going to be 72. So I think there's only one. So subtract 36. 7 minus 6 is 1. 5 minus 3 is 2. Bring down my 9. Well, I already know that 36 times 2 is 72. So I'm going to have to go bigger than 2. I'm going to do 36 times, let's see, what should I try? Let's try 6. See how we get to, oh, I didn't bring down my 9, did I? Uh-oh, that got bigger, didn't it? All right, 36 times 6 is 36. 6 times 3 is 18, 19, 20, 21. Oh, that's kind of perfect, isn't it? All right. All right, let me write that down. So 216 and 6. And I have 3 left over because that's 0 and that's 0. So I'm going to bring down my 6. How many 36s are in 6? 36. 1. So this answer is going to be 161. Whew, that's a lot of work, but notice I did show my work for each separate problem. Showed my work here, 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 and here. So make sure that you are also showing your work when you do this kind of work, okay? So that you can find your mistakes if you have any. All right, let's go to the synthesis and see what they ask me about this one. How did you find the missing measurements? So how did we do that? Well, we multiplied the length and the width together to make sure it gives us the area, right? So that's how I knew that I had to find, how did I do it? Sometimes I had to multiply, sometimes I had to divide. How can we make sure that we found the correct missing sides? Multiply the length and the width together to make sure it gives us the area, right? Or check with division or check with multiplication. How is finding the area of the rectangle using length and width different from finding one side of length using the area and the other side? Well, when I had the length and width, all I had to do was multiply to find the area. When I only had one side and the area, I had to divide. So it was much different. All right. Find the missing side length, part 2. So again, here we have volume this time. Volume this time. Remember, volume. The formula for volume is length times width times height, or the area of the base times the height. And I think that's what they gave us. They gave us the area of the base times the height gives us the volume. So again, I can just take that area because it's already, these two are already multiplied together, and I can divide it. So 15 into 375. So how many 15s in 3? None. How many in 37? I think there's going to be 2 because I know that 2 times 15 is 30. And that's going to leave me with 7. And I'm going to bring down my 5. So 15 times what is 75? Let's try 5. 5 times 5 is 25. 5 times 1 is 5, plus 2 is 7. So there it is. 5 times 15 is 75, and we have 0 left over. So 15 times 25 is 375. Again, this time they did not give me the area of the base. They gave me the height, and I have to figure out the area of the base by doing, again, division. 28 goes into 1,176 how many times? Well, 28 won't go into 1. There are no 28s in 11. So how many 28s are going to be in 117? Let's do 28 times 3. 3 times 8 is 24. 3 times 2 is 6, 7, 8. That's 84. I think it might be a little bit bigger than that. So let's try 28 times 4. 4 times 8 is 32. 2. 4 times 2 is 8, 9, 10, 11. Okay, that gets me much closer, right? So 4 times 28 is 112. 7 minus 2 is 5. And 11 and 11, that doesn't. And so I'm going to bring down the 6. Well, I did 28 times 3, and that is too big, right? That's too big. I need something smaller than 56. So let's go over here and do 28 times 2. 2 times 8 is 16. 2 times 2 is 4, plus 1 is 5. Oh, that goes out. That works out evenly, right? 2 times 28 is 56 with no leftovers. So 42 times 28. 42 times 28. Again, I've shown all my work, and I have not erased any of it so that my teacher and I can go back and check over it if I got any of them incorrect. Okay, let's look at what they want us to do next. Nice job, girls and boys. Okay, Claire wants to find the height of the rectangular prism with the following measurements. Aha. First, Claire finds the quotient of 882 divided by 6. What could she do next? Well, after she found 882 divided by 6, she would have to find that quotient and divide it by 7, wouldn't she? She sure would. So let's go ahead and do that so we can find out what the next step would be. So 882 divided by 6. 6 goes into 8 one time with 2 left over, and then we bring down the 8. 6 goes into 28. What is that? 4 times? 4 times 6 is 24. With 6 left over, that can't be right. Must be 5 times. No, it's 4 times. 4 left over, Miss Lemoyne. 4 left over, not 6. Okay, then I can bring down my 2. All right, 6 goes into 42. I know that that goes in evenly 7 times. So now I'm going to, that's this and divided by this, right? This divided by that. So 882 divided by 6 equals 147. Now I have to divide that by 7, don't I? So 147, that shouldn't be too hard. 7 does not go into 1, but it goes into 14 2 times. 2 times 7 is 14. And then I only have 7 left over, don't I? And 7 will go into 7 one time. So I think that the height is 21, right? That's what I think. I think the height is 21. Because if I multiply 21 times 7 and then that times 6, I should get 882. All right. Good work. All right. Complete the table to find the missing side links for each rectangular prism. So I can do 936 divided by 8 and then take that answer and divide it by 9, right? There is a different way to do that. I could take 8 times 9 and then divide that into 936. So I know that because I know my math facts, that 8 times 9 is 72. And 72 will go into 936. Now you could do both division problems. You don't have to do it the way Miss Lemoyne is doing it. I think it will not go into 9, but I think it'll go in here one time, 72. And I have 21 left over. Bring down my 6. Well, I know that if I divide 21 by 7, I think that's 3. So I can go over here and do 72 times 3. 3 times 2 is 6, and 3 times 7 is 21. So yeah, that works. 3 times 72 is 216. So I'm going to say that this number would be 13, that missing number. So I did it a little bit differently than Claire did in the last problem. I'm going to also do this one a little bit differently as well. I'm going to multiply 48 times 2 first. 2 times 8 is 16. 2 times 4 is 8, plus 1 is 96. So when I multiply these two together, I get 96. Now I'm going to just divide one time. 96 will go into 1,536. Well, it won't go into 1. It won't go into 5. Let's see. 96 times 2 is 12, 18, 19. So I only think it goes in one time. 96. Right? Subtract that, bring down my 6 first. Okay, so I'm going to borrow 1 from the 15 and make that a 14. And that makes this a 13, right? So 13 minus 6 is 7, and 14 minus 9 is 5. So now I have to get to 576 because I brought down my 2. So 96. So when I do these kinds of problems, girls, I kind of ask myself, how many times will 9 go into 57? And I know that, let's see, this is really messy. 9 times 7 is 63. 9 times 6, so let's try 6. 96 times 6, because 9 times 6 is 54, and that's close to 57. So 6 times 6 is 36. That's going to be 54, 55, 56, 57. Look at that. 576. There we go. So I think that this is going to be 16. Now this last one's pretty hard, right? The last one's pretty hard because they haven't given us 2 of them. So the first thing I'm going to start off by doing is I'm going to divide these two numbers. 36 goes into 1008. Well, 36 won't go into 1. It won't go into 10. So I have to go into 100. Well, I know that 3 30s is 90. So let's try 36 times 3 and see what that gets us. This is 18. That's 9 and a 10. That's 108. That's too big. So I'm going to do 36 times 2. That's 12. 6, 72. So that's going to be a 2. 2 times 36 is 72. Now I'm going to subtract, right? So I have to borrow 1 from the 10 and make it a 9. So 10 minus 2 is 8. 9 minus 7 is 2. And I'm going to bring down the 8. All right. Well, I know it's going to be way bigger than 3. So let's try 36 times, what do y'all think? 5? 5 times 6 is 30. 5 times 3 is 15, 16, 17, 18. Ooh, it's going to be way bigger than 5. So let's try 36 times, let's see, 6 times 8. 6 times 8 is 48. 8 times 3 is 24, plus 4 is 28. So it's 8. So it's going to be 28. So these two numbers together, when they're multiplied, they're going to equal 28. So do we just guess at what two numbers we can multiply to get that? So I guess we could put So what makes 28? 4 times 7. So we can make it 4 and 7 or 7 and 4. That one we really don't know, right? We really don't know. All right. What numbers would you use to get to 28? I bet there are more than just 4 and 7. Okay, let's move on. How did you find the missing side links? How did we find those missing side links? Well, we multiplied, didn't we? What are some different ways, and we divided too. What are some different ways you can find the length of this? Well, we could divide 1,536 by 48 and then divide that quotient by 2, or vice versa, right? I can first divide the volume by 2 and then divide by 48, and that would be the answer. Which method did you prefer? I liked combining these two because I only want to divide one time, but that's just me. Which method do you prefer? Today we found missing side lengths of rectangular prisms using division. What is the value of 1008 divided by 36? What was that value? We did divide it already, right? Do you remember what it was? Divided by 36? I think it was 28, right? 28. Why is there more than one solution for the width and height for this one? Because there are more than one way to get 28, right? We could get 4 times 7. We could do 2 times, what? 2 times 28 divided by 2. We could do 2 times 14, right? There are lots of different numbers here. And we could do 1 by 28, couldn't we? We could. There's lots of different things. We could do 7 and 4 instead of 4 and 7. Okay. Here's our cool down. Let's get started on our cool down. The area of a rectangular garden is 832 square feet, and its length is 16. So here we go. I'm going to draw it. Here's my rectangular garden, and the length is 16. I do not know its width. Oops. I don't know its width, but I know that 16 times something is going to give me 832. So I'm going to have to divide to find the answer. So 832 divided by 16. Well, there are no 16s in 8, right? How many 16s are in 83? So let's try 16 times 5. Let's try that first. 5 times 6 is 30. 5 times 1 is 5, plus 3 is 8. Well, that got me really close, didn't it? 5 times 16 is 80. And then I'm left with 3, and I bring down my 2. Well, let's see what 16 times 2 is. 2 times 6 is 12. 2 times 1 is 2, plus 1 is 3. So it's 52. So the width of this garden was 52 feet. The length was 16 feet, and the area was 832 feet squared, or square feet. Right? Awesome job. So that's a lot of practice with area and division when we're missing a side length. Good job today, boys and girls. I will see you for lesson 16.